Section 8.1 talks about variables. And so let's read through some of this info that we have right here so that we can understand this concept. So it says in basic arithmetic, we have fixed numbers or constants, as in 4 plus 3 equals 7, but a major concept of algebraic thinking is that of a variable. It says a variable may stand for a missing element or an unknown, as in x plus 2 equals 5, which we have here. It says a variable can represent more than one thing. For an example, in a group of children, we could say that their heights vary with their ages, so h represents a height and a represents the age. Then both h and a can have different values for different children in the group. A variable can be used in a generalization of patterns, and a variable can be an element of a set or a set itself. For example, in the definition of the intersection of two sets, A intersection B, that's how I read this. A intersection B. It's just telling me that I'm looking for the elements that belong to both. Okay. So it says to solve problems algebraically, we translate given information into mathematical expressions involving variables designated by letters. In the school book page on page 430, simple word statements are translated into a bar diagram and then into an algebraic equation. A statement of equality between two expressions. An algebraic expression typically contains one or more variables but has no equal sign and is not an equation. All right, so let's see if we can figure out these first few problems that we have here. Let me get a different pen. And it says, in each of the following descriptions, translate the given information into a symbolic expression involving variables. The cost of renting a car for any number of days at $40 a day. Okay, so we want to find the cost of renting a car for a number of days at $40 a day. So how about if we say D is going to be the number of days, and since it costs $40 a day, we would just say 40D would be the expression that describes what they're asking me to find in part A, okay? So notice, since we're finding expressions, we're not going to have an equal sign, we're not going to have an equation, okay? All right, part B says the distance a car traveled at a constant speed of 65 miles an hour for any number of hours, okay? So how about again if we say H is going to be the number of hours, okay? And so how far did we travel? Well, 65 times however many hours we traveled, okay? So this would be my expression for part B. Okay, so let's take a look at the next one here. It says, one weekend, a store sold twice as many 8 gigabyte, flash drives as 64 gigabyte flash drives, and 25 fewer 256 gigabyte drives than the 8 gigabyte drives. If the store sold D 64 gigabyte drives, how many 256 gigabyte drives and how many 8 gigabyte drives did it sell? Okay, so let's take a look at it. The first thing it says is that D is going to stand for the number of 64 gigabyte drives, right? Okay. Now, look what they're talking about. They're talking about how many 8 gigabyte drives. So it says we sold twice those. So then 2D would be the number of 8 gigabyte drives. Okay. And let's see. We sold 25 fewer 256 gigabyte drives than we did of the 8. So however many number of the 8 we sold that number minus 25 would be the number of 256 gigabyte drives. Okay. So a big part of this here, y'all, is how can I read these sentences that are written in English and translate them into algebra, okay? So one of the things that really helped me with this problem is when they gave me this piece of information right here. and it said, let's let D be the number of 64 gigabyte drives that we sold. And then everything is being compared to that number, right? We sold twice as many 8s than we did of the 64s. So 2 times whatever we sold for the 64s would be the number of 8s. And then we sold 25 less of the 256. So whatever we sold of the 8, we're just going to subtract 25 because it was 25 less. Okay? All right, and there's a part D. Let's see if we can figure out part D. It says French fries have about 3 calories apiece, and a hamburger has 250 calories. Mateo is on a diet of 1,200 calories per day. If he ate F French fries and 1 hamburger, how many more calories can he consume in that day? Okay, so let's figure this out. Let's see if we can do this in pieces. So we know that a burger, according to what they told us here, has 250 calories, okay? And the fries have 3 calories, okay? So let's see if we can figure out how many calories is he going to consume. Well, we know he's already consumed 250 because he ate the burger. And then notice what it's telling me. F is going to be my number of fries. So F is the number of fries. And each fry has a total of 3 calories. So 3 times F. That's how many calories he's consumed at this point. Okay. The question, though, is telling me how many calories can he still consume? How many more calories can he consume in that day? Meaning, how many calories would be left? Okay. So remember, how many calories? He's on this diet, and Mateo is restricting himself to 1,200 calories. So we're going to say, let's take our 1,200, and we're going to subtract this whole thing right here. Guys, since I'm going to subtract all of that, I'm going to put it in parentheses. Okay. Now, when I'm subtracting this, you might remember this from algebra. I'm going to think of this number here being a -1, and I'm just going to distribute that -1 to both pieces. So now I'm going to have 1,200 minus 250 minus 3F, okay? And I'm going to pull up my calculator. I'm just going to use, you don't have to use a graphing calculator, guys, but I have it right here on my computer, and it just makes it easy to pop up, okay? So now I'm going to take 1,200. I'm going to subtract off 250, and I want to say that's going to give me, 950. So this is going to be 950 minus 3F. And that's how many calories he still has to consume within that day. Okay. All right. So let's take a look at the next problem here. All right. So the next part here says an arithmetic sequence is determined by its first term and the difference. A recursive formula for the arithmetic sequence is found in chapter 1. Now we're going to find an explicit formula for an arithmetic sequence. Okay, so we're going to kind of cut to the chase here, and we're going to look directly at the formula. So the formula says, it's right here, that the nth term of a sequence is given by this formula right here. And this formula just says an equals a1, which is the first term, plus n minus 1 times d. D is going to be the difference in the terms, okay? So let's see if we can figure out the first problem here. And it says, find the nth term in the sequence. Okay, so just by looking at this piece here, I know that my A1 is going to be 5 because that's the first term, okay? Then the next thing we want to do is we want to find the difference. So what we mean by the difference is we're going to subtract those numbers. We're going to take the second number minus the first. 9 minus 5 is 4. And we can do that a few times if we want to. We can do 13 minus 9. Notice still 4. If I take 17 minus 3, still 4, so on and so forth. Okay? So we know that the first term is 5, and we know that the difference in the terms is going to be 4. So now I'm going to use this formula right here to write out a formula for the nth term. So I'm going to say an equals a1, which we found to be 5, plus n minus 1 times d, which we found to be 4. Okay. I'm going to leave this 5 alone. I'm going to go ahead and distribute my 4. So 4 times n, let me get my pen. Sometimes my pen freezes up, guys. Give me un momento, por favor. Let me see if I can get it. There we go. Okay, so 4 times n is going to be a 4n. 4 times minus 1 will be a minus 4. Now I can combine those numbers there, and we'll say an equals, let me write this piece first. It really didn't matter how I write it. 4n, 5 minus 4, positive 1. And there's my formula for the nth term of that particular sequence. Okay. So now, let's take a look at this next problem. And I'm just going to kind of give myself a little bit of room to do this problem here. And it says, in an arithmetic sequence where the second term is 11 and the fifth term is 23, we want to find the 100th term. Okay, so let's start off with what we know. We know that the formula an says it's going to be a1 plus n minus 1 times d. That we know, okay? And if we were to now to say, well, look, we have the second term. So since we have the second term being the number 11, and we have the fifth term being the number 23, what this means is that because we're talking about the second term, my number n is 2 for the second, and in this part, my number n is going to be 5 for the fifth. Okay, so let's do this. Let's say a2 is going to be, I still don't know what this a1 is, so I'm going to leave that alone. Remember what we said was, we said over here, since we're talking about the second term, the number n is 2, so right here I'm going to put 2 minus 1. I still don't know what the letter d is, okay? I don't know what the letter d is. But I know that the second term is also equal to the number 11, okay? So here is something about my second term. You know, we can actually fix that a little bit more. Let me, before I put the box around it, let me do a little bit more work. How about if we say a1, 2 minus 1 is just 1, and 1 times d is just d. That's going to be 11, okay? So here's my second term, okay? Let's do the same thing for the fifth, okay? So the fifth term is going to say a5, because it's the fifth term. Again, I don't know anything about the first term, so I'm going to leave that alone as it is. Remember, because I'm talking about the fifth term, my number n is the number 5, so I'm going to put right here in parentheses 5 minus 1 times d, okay? And I know that the fifth term is equal to the number 23, okay? So we can do a little bit of work right here. I know 5 minus 1 is the same thing as 4, so that's going to be, what, 4d equals 23. This is my fifth term. Okay? So what we're going to do now, we need to find something. We have two pieces of information that we don't know. We don't know what the A1 is, and we don't know what the letter D is, okay? So how about if we say, let's take the fifth term and let's subtract the second term, okay? Well, we know that the fifth term was the number, what, 23? And we know that the second term was 11, okay? And so I know that 23 minus 11 is just going to give me 12, but we also have a formula for the fifth term and a formula for the second term. So the fifth term is A1 plus 4D, right? Minus the second term was A1 plus D, okay? So I'm going to think of this as A1 plus 4D. Remember, we can think about this as a negative 1. All that's going to do, my friends, is just change our signs. Okay. So first thing I want you to notice, the A1s are going to go away. 4D minus another D is a 3D equals 12. If we divide both sides by 3, That tells me that D is equal to 4. Okay, so now we got somewhere. There were two pieces that we didn't know. We didn't know what the number A1 was, and we didn't know what the letter D was, and now we found the letter D to be the number 4. Okay? So this is what I'm going to do now. I'm going to come back. It doesn't really matter which one of these two I'm going to use. I'm going to use this one just because my numbers are a little bit smaller. And I'm going to say A1 plus the number D, which we just found to be 4, is going to be equal to 11. So now if I take away 4 on both sides, A1 is now equal to 7. Okay, this is perfect because now I know both those pieces that I was missing, right? Now, I don't know about you guys, but I already forgot what it was asking me to do. So let me come back up here at the top. The question was asking us, can we find the 100th term? You know what? I bet you we can. So I'm going to look at my formula right here, right? And it says AN equals A1 plus N minus 1 times D. So I'm going to write that out. But now we're finding the 100th term. So I'm going to say A100 is equal to A1, which we found to be 7, plus N minus 1. Well, 100 minus 1 is 99. I got 99 problems. But hopefully arithmetic sequences aren't one. I know that was cheesy, guys, but it's 10 o'clock at night. I'm trying to get this done for you guys. Okay, so let's multiply 99 times 4. Let me get my calculator. It's right here. Turn it back on. Oh, turn it on. There we go. 99 times 4. And 396. And if we just add 7 to that, let me bring my calculator back up, plus 7, what are we coming up with? 403. There we go. Okay. And so we found our 100th term. Oops. There we go. Okay, so the next part here says generalizations for geometric sequences. Okay, so now we have something called the geometric sequence. All right, so again, I'm going to cut to the chase. This here is going to be my formula for the nth term, okay? So for the nth term, we're going to have A1 times r to the power n minus 1, okay? So A1 is still going to be the first term. R is going to be what we call the ratio, okay? And it's going to be the ratio of consecutive terms. Okay, so let's see if we can figure that out for this problem here, okay? I want to show you how I'm going to do this. Again, the directions are pretty straightforward. Find the nth term of the geometric sequence. Okay, so the first number is 3, 12, 48, 192, so on and so forth. So we know from the get-go that A1 is going to be 3. Now let me show you how we're going to find R. R is the ratio. A ratio means we're going to divide, okay? So if I were to take the second term and divide it by the first, 12 divided by 3, I get 4. I can do the same thing with the next two terms. 48 divided by 12, I get 4. So on and so forth. It's always going to be like that, okay? So now we can write out our formula. So it's going to say AN equals A1 times r to the power n minus 1. So AN equals the first term, which is 3, times, I'm going to put it in parentheses like this. I guess you don't really need to put it in parentheses, but I'm going to n minus 1, okay? And I'll put my little dot right there to let me know that I am multiplying, okay? All right. So let's see if we can do the same thing for the next problem. We're going to find the nth term of the geometric sequence, okay? So this is just like the problem that we just did right now, okay? So AN equals A1 to the power R n minus 1, okay? So let's get started. The first term I know is 2, and let's find our ratio. I'm going to take this number, divide it by that one. 3 divided by 2, there it is, right? You can say, well, what happens when I take this one and divide it by that? Okay, so look, let's write it out. 9 halves divided by 3. So remember from like basic math, you can think of this number as 3 over 1. And then do you remember how to divide fractions? I know you're going to tell me yes. We change it to multiply, and then we take this guy and we flip him. And when we flip that, this 3 can reduce with that 9. 3 goes into 3 once, 3 goes into 9 3 times. And when I multiply straight across, 3 times 1 is 3, 2 times 1 is 2. And if you notice, I get the same thing, jelly bean, right? Okay. So now my formula is going to be AN equals A1, which is 2, to the power 3 halves and minus 1. Okay. Let me scroll a little bit more. Okay. And let's do part B. Okay. My pen is freezing up. There we go. Okay, so look what it's telling me. It's telling me here that the first term is 3. So A1 is 3. And R equals the square root of 2. We want to find the 10th term. Okay, so let's see if we can do that. So AN equals 3 times the square root of 2 to the power n minus 1. Okay. So now let's see, we're going to find the 10th term. So A10 is going to be equal to 3 square root of 2. 10 minus 1 would be 9. Okay, so we didn't talk about square roots in this class, but you guys have had college algebra, so you should know a little bit about square roots. But I'm going to give you a quick breakdown. Square roots means I am looking for pairs, okay? As in 2, all right? Not necessarily this number 2, but pairs. So I want you to think about what does it mean to raise something to the 9th power? I'm doing this, guys, because I care about you, not because I like writing the number the square root of 2 9 times. 1, 2, 3, 4. Still got to do this 5 more times. 1, 2, 3, 4, 5. Okay. Now remember what we said. We're going to get pairs. So I'm going to leave this 3 alone. That's 1 pair. That's 2 pairs. 3 pairs. 4 pairs. Whenever I have a pair of whatever the number on the inside of the square root, that number I'm going to write it down. So here's a pair. What's the number on the inside of the square root? 2. Here's another pair. What's the number on the inside of the square root? 2. Here's another pair. What's the number I'm going to write down? 2. How many pairs did we have? We had 4 pairs, and then we had 1 left over. Okay? So now all I'm going to do is grab my calculator one more time, turn it back on. 3 times, we had how many 2's? 4 2's? 1, 2, 3, 4. Okay, and that's the number 48. So A10 equals 48 square roots of 2. Okay. All right, let me scroll down a little bit and we'll do this next one. Okay, so the next part here says, let me get my pen going again. There we go. Okay, write an algebraic, look at the word it's telling us here, equation. Remember what an equation means? Equation means I'm going to have an equal sign. Relating the variables described in each of the following situations. Okay, so part A says the pay P, so P stands for my pay. T is going to be the number of hours if we're paid $16 an hour. Okay, well that's pretty straightforward. My pay is going to be 16 times however many hours I work, right? Okay. Let's do part B. The pay P for T hours, if you're paid $28 for the first hour, and then $23 for each additional hour. Okay, so let's do it this way. So the first hour I work, I'm going to get $28. And then they're going to give me $23 for every hour I work after that. Okay, because it's going to be after the first hour, I'm going to have to subtract 1 because that'll be after my first hour. Okay, so I can leave it like that. It'll depend. If this is a multiple choice problem in your homework, then it might just leave it this way, or you might have to do a little bit of work. So that might be one of the choices. If not, then let's go ahead and do some work. So we'll multiply. That's going to give me 23t minus 23 plus 28. And so this will be 23t minus 23 plus 28 should be a plus 5, right? Like if I owed you $23 and I had 5, or I had 28, I'm left with 5. Alrighty. So the next problem here says, write an expression in terms of the given variables that represent the indicated quantity. So it says Joe's total earning after 3 years. His total earning. This doesn't mean what he made in the third year. It means what did he make over all 3. Okay. His first year salary was S dollars. So in year 1, he made S. Okay. The second year, it was $9,000 higher. So whatever he made first, plus another, 9,000. There we go. The third year was twice as much as the first year. So whatever we had here, we're going to multiply it by 2s. Now we want to know the total earnings, okay? So the total is going to be, we're going to add them all up. So S plus another S is 2S plus another 2S, 4S plus 9,000, right? Okay. And that was 8.1.